Hello there, welcome to our channel. So for today, we're going to talk about factoring trinomials. Let me show you the screen. There you go. So for factoring trinomials, the first step, you're going to identify each terms. So let us use this marker. So the first number is what we call quadratic term. So I will just write QT in here for short, in short, QT. Okay, quadratic term. And then for the second term, we have the linear term. Okay, let me just write LT in here for linear term. And then for the last term, we have the constant term. Constant term. Constant term, constant term. So those are the three terms for trinomials. That is why they call it trinomials. From the prefix word tri means three, nomials mean terms. So we have three terms in here. And then we will apply the factoring method. Since it doesn't have a numerical coefficient in here for our quadratic term, it is easily to apply the factoring method to solve the roots or the solutions or the x-intercepts and or the answers for the value of x in here. Remember and take note that solutions, root zeros, and x-intercepts are all just the same. So we're applying the factoring method in here since we do not have a numerical coefficient in our quadratic term. So for the next video, I will give more example about trinomials with the numerical coefficient on the quadratic term. So wait for it. Okay, so the first step, as I mentioned a while ago, we name the three terms: the quadratic term, the linear term, and the constant term. Okay, next step, I want you to show the steps organizedly. So let us create a, a table. Okay, let me use a 3 square in here. Okay, this one and then another one, Control C and then Control V. Okay, there you go. Let us move this one. So I will use three tables in here to make it more organized and clear. Though, yeah, we can solve it without using those tables. But I want to show my presentation organizedly. Okay, so for the QT or quadratic term, let us write QT in here. Oopsie, we will use a blue marker, okay, to make our presentation more organized. So for QT, we'll write QT in here, the quadratic term, which is the x squared. Okay, so we write x squared in here. For the linear term, we will also specify it. For the linear term is the 3x. So let us use 3x in here, 3x. And for the constant term, we have positive 2 in here. Okay. So step 1, to apply the factoring method, okay, we'll concentrate on the constant term, which is 2. Okay. So we'll concentrate on the constant term, which is 2. That is the second step. After identifying the terms, we'll focus on the constant term. That is the second step in factoring method. So we're going to look for the factors of 2. Factors, these are the two numbers that if you multiply them, you will get another number. Okay. So we're looking for the factors. Factors. Okay. Okay, what are the two, what are the possible, all the possible factors for 2? Okay, when we multiply them, we can get 2. So we have 2 times 1. Okay, and also we have also a negative 2 times negative 1. These are all equal by positive 2. Is there any more factors for 2? Let me know. Just comment your answer if you still know factors for 2 that we can get 2 when we multiply two numbers. Comment on the comment box below. Okay, next. Then I think these are all the possible factors for 2. When we multiply those two numbers, we'll get the constant term. Next step, for the third step, we're going to get the addends. Find the addends for the numerical coefficient, okay? For the numerical coefficient of the linear term. Why? Okay, because we're looking for a common number that will satisfy the factors and the addends for the linear term. The factors for the constant term and for the addends for the linear term. Take note. Addends are the two numbers that if you add them, you will get the linear term, which is 3. Okay, think two numbers, two addends, that if we will add them, we will get 3. Okay, so we can get 2 plus 1 is 3. 2 plus 1 is 3. Another number we have 3 plus 0. Okay, 3 plus 0. Okay, so those are all the possible addends for the numerical coefficient of the linear term, which is 3. Okay, then after that, for the fourth step, okay, let us recall them. Step 1, name all the terms, quadratic term, linear term, and constant term. We will identify the 3 terms. And then step 2, you will factor the constant term. You will focus on the constant term and then you factor them. Find all the possible factors. Step 3, okay, step 3, you will concentrate on the linear term. Okay, find all the possible addends. Find all the possible addends that if you add those two numbers, you will get 3. Okay, and then for the next step, okay, look at the common factors. Look all the common factors that satisfy, or common numbers that satisfy the factors of the constant term and the addends of the linear term. Okay, so I can see same number in here, which is 2, 1, and then 2, 1 in here. Those are the numbers that satisfy the constant term and the linear term. Okay, I will repeat. Look for the similar numbers that satisfy the factors of the constant term, which is 2, and the addends. When you add those two addends, you will get the sum, which is the numerical coefficient of the linear term, which is 3. Okay, take note of that. Don't get confused. You may just replay the video if I'm too fast in discussing it, but please let me know if it is too fast and I can give you more example on the comment box. Okay, next one, we have the quadratic term. So we're going to factor the quadratic term in here. Okay, so we have the quadratic term, which is x and x. The factor of the x squared is x and x, because x times x is x squared. You add the two exponent. So if you see a whole number or a number without an exponent, that means they have an exponent of 1. Under the laws of exponent, we will add the exponent if it is multiplication. So x to the first power times x to the first power is x squared. That's why we got x and x, two x's. Okay, and then the next step, okay, we'll proceed on the next step. We will have, I am drawing in here a two groups, a parenthesis, okay, in which I will factor the trinomials x squared 3x plus 2. And these boxes that we did in here will help us to find the perfect factors. Okay, then the next step will distribute the x. So we have x in here, we have two x's, x and x. Then after that, we will write the first number, the common number that satisfy the constant term and the linear term in terms of factors and addends. Okay, so we have positive 2. Don't forget the plus sign. If it is negative, minus sign. If it is positive, it is a positive sign. And then the other one is positive 1. There you go. So those are the factors. Okay, those are the factors. We already factored it. Now, to find the roots, we're looking for the roots, the value of the x, okay? In terms of factors, those are the factors. If it is asked you factors, factor the trinomials, those are already the factors. Now, if they will ask you what are the zeros or the roots, we will apply the ZPE to equate both equation by zeros to find the value of x. What is ZPE? ZPPE is the zero product property of equality, in which we will equate the two statement into zeros. Okay, so we have x plus 2. We'll equate it into 0 to get the value of the x. Okay, equals 0. Then we have x plus 1. X plus 1 is equal to 0. Let me put an arrow on this one so that you will not get confused. Okay, you may also draw parentheses in here. Then after that, okay, since we equate them into 0, we can now find the value of x by moving the constant on the other side. So it will cross the equal sign. The rule is when a number crosses the equal sign, we change its sign number. So from positive, it will become a negative in here. Likewise on the other side, so it will become negative 1. From positive 1, because we're moving it on the other side, we'll change the sign. Don't forget it. That's the rule. When it crosses the equal sign, you switch the sign. So from positive, it will become negative, and vice versa. From negative, it will become positive. Okay? And then, those now are the x-intercept or the zeros. Or you may also write your answer in the form of bracket format. Okay? So we have negative 2 and negative 1. Don't forget the comma. That is very important. And then we will going to highlight our answers. Okay, let us box our answer or encircle it. Okay, let us highlight the answer. So this is the answer, the roots. Okay, for the x-intercept, we can also highlight the x-intercepts. X-intercept, this one and this one. Okay, hold on, square. There you go. For the factors, we can also write the factors. If they're asking you for the factors, these are the factors. Okay. Take note, we just have the same answer. Okay. So I will just write in here, I will just highlight this one. Which color I didn't use yet. Okay, so let us use the yellow one. So again, these are the factors of the trinomials. Okay, let me just clarify this one. These are the factors of the trinomials. And these are the x-intercepts or zeros. X-intercepts. So they wrote them in a different format, but they are just the same. Okay, x-intercepts. Okay, and these are also what we call the roots and solutions. Roots and solutions. Just to clarify them, okay? Solutions. So factors is different from x-intercept, roots, and solutions, okay? These are also what they call zeros. Another term is zeros, okay? Zeros, because we equate them into 0. Okay? So the four terms are just similar, but factors is different, okay? So x-intercept is equal to the roots is equal to the solutions, and solution is equal to the zeros. So that's all for the factoring trinomials. And if you need an example, just continue watching the video. Okay, let us proceed on the next slide. For the next slide, we'll find the roots of each quadratic by factoring. So I will answer this one in a quick way so that we can finish it earlier. Okay, so the first part is very detailed, and if you need to slow it down, just rewatch the video. Okay, so in here, again, we'll identify the quadratic term, linear term, and constant term. Okay, so we'll focus first, step 1, we'll focus on all the factors of 2. What are all the factors of 2? Okay, so we have 2 times 1 or negative 2 times negative 1. Negative 2 times negative 1. Okay, we can use parentheses for exponent. So those are all the possible factors for 2. And then next step, after identifying the factors of the constant term, we're going to move on the linear term. For the linear term, we have negative 3. What are all the add-ins? Two numbers that if we will add them, we can get negative 3. So these are all about integers because it is negative. Okay, so we can use -2 plus -1. -1. We can also use -3 plus 0. It will gives you also -3. However, take note of this one. Okay, however, let us highlight it. However, we're looking for the similar terms or similar number that satisfy the constant term and satisfy also the linear term. Okay, so in here we have the same number, which is -2 and -1, that satisfy the factor of the constant term and satisfy also the sum. Okay, the sum, when you add them, you will get -3. Okay, the perfect addends for -3 and the perfect factors for +2. Does make sense? So that's why we will choose these two number, -2 and -1, because it satisfies both linear term and constant term. Take note of that. Okay, because you will get confused if the constant term have a lot of factor that will be in letter B. We'll proceed on letter B later. Then the next one, we're going to factor the quadratic term, okay, which is x squared. So we have x and x. X times x. Okay, so there you go. Very easy and simple by solving trinomials or quadratic by factoring method. Then after that, you factor the constant term, you find the addends for the linear term, you factor the quadratic term. Now we'll throw a parentheses, two groups of parentheses in here because we have a second degree. Okay, and then we'll distribute the x and x in here. Take note, we have -2, so we will use -2 in here because we have -2. Same as with -1, we'll use -1 there. Okay, and then we'll equate it into 0. After that, we will apply the ZPE or the zero product property of equality. We'll equate both equation by 0. X minus 2 is equal to 0. Yippee! And then x minus 1 is equal to 0. Okay? Then after that, to find the roots, the solution, the zeros, okay? What more? The x-intercepts, okay? These are already the factors. Let me highlight them. So I repeat, if they are just asking you for a factors, these are already the factors, okay? These are already the factors. But take note in here, let us highlight this one. Let me just, for a word problem, it says that we need to find the roots, okay? The roots. The roots. So therefore, the value of the x. So these are the factors. So let me just write factors in here. If they're asking you, if the problem asking you about the factors, you may stop there. Okay, because you already factored the trinomials, which is x squared minus 3x plus 2. But in here, they're asking us for a root. So we will look for a zeros, roots, or solutions. Okay, so now x will move the -2 on the other side, crossing the equal sign again. So from -2, it will become +2. Perfect. Next, we have in here, so the inverse, because it crossed the equal sign in here, we'll move it constant. So we have +1. So therefore now the solutions or the value of the x, okay, we may now write equal sign in here. So we have 2 and +1, okay? Very good. So let me know if you have questions, and this is for you. 2, 1. Okay, so that is for you. And then we will answer letter B. For letter B, same what we did a while ago. First step, we'll need to find the factors of the constant term, which is 12. So now the constant is 12. We have a numerous number for factors of 12. So we were going to pick and choose the two numbers that satisfy also the linear term in terms of its addends. And we add the two number, we will get the sum of 7 because that is the linear term. Okay, let us first get all, okay, let us first get all the factors of the 12, the positive 12 in here before we'll proceed, okay? So what are all the factors of 12? So we have 2 times 6, yes, it satisfies 12. Okay, let me just put parentheses so that you will not get confused because we're multiplying for factors. And then we have also 3 and 4. 3 and 4. Okay, we have also 12 times 1. 12 times 1. And take note, we can also use negative numbers for factors. Remember that negative times negative will give you positive. So you may use also negative 2 times negative 6 in here. Same as with negative 3 times negative 4. And then we have also negative 12 times negative 1. There you go. Let me know and comment on at the below if you have on your mind another factors of 12 that we miss. So please let me know, okay, on the comment box, and then we'll add it up, okay? Share it. Okay, next. After identifying all the factors of the constant term, we're going now to look for the addends for our linear term. Again, these are, in here, we're looking for the factors. On the linear term, we're looking for the addends. On the quadratic term, we're looking for the factors too. Okay, FAF. Okay, now what are the addends? What are the numbers that if you will add them, you will get, if you will add them, you will get 7. So we have 5 plus 2 is 7. Okay, so I will just add plus in here. We do not have 5 and 2 in here, so we'll get more another addends. So we have 4 plus 3 is 7. Yay! So there you go. So I can see now 8 common numbers in here that satisfy the factors of the constant term and the addends for the linear term. They are both have 3 and 4, positive 3 and 4. We can also proceed, but I think we can stop in 4 and 3 since we already satisfy the needed numbers that satisfy both constant term and linear term. Okay, we may also add 6 and 1 in here, but there is no 6 and 1 on the constant term. So we'll focus on 3 and 4. Let us highlight them. Again, don't get confused on that. We're picking a number, both numbers, that satisfy the constant term and the linear term. So we're going to concentrate to positive 3 and positive 4. Then after that, we're going to factor the x squared. We have x and x. Okay, let us change it into a marker. So we have x and x in here. Okay, after that, you're going to factor them, find the factors. Very easy. When you see the common numbers, you will just distribute the x and then another x. And then we have positive 3 and positive 4 on the other side. Positive 4 and then positive 3. Okay, so these are all the factors now. We can highlight the factors. We already find the factors, but the problem is we're looking for the roots. So we will use those factors to find the roots. Just extend this one. Okay, to find the roots, we'll just equate both equation by 0. So x plus 4 equals 0. 0. And then x plus 3 equals 0. Okay. So x plus 3 is equal to 0. And then we'll move the positive 4 on the other side. We're separating the variables to the constant. So from moving it, positive 4, it will cross the equal sign. So we'll change the sign. Don't forget it. It will become negative 4. Same as in here. So it will become negative 3 because we move them from left to right. Okay? Let me just put an arrow in here so that you will not get confused. Why is it from positive it became a negative? Because it crossed the equal sign. Okay? And then we may also write our answer by throwing a bracket in here. So we have negative 4 and negative 3 for our root solutions, x-intercept, and zeros. Awesome. Okay. So let me just highlight our answer for the roots. Let me encircle them. So it's up to you if you will use x equals number, the number, or you may use bracket. So, and also it depends on the test, on the major test. Just don't get confused on that. Okay, you may present your answer by bracket or by the value of the x, given the value of the x with an equal sign. Okay, so as I mentioned, I believe in mathematics, there's no retention without application. So now it's your turn for you to answer these two problems. Okay? Right, don't forget to subscribe. Don't forget to subscribe. See ya.